So when y is 1/2, u is what? 3/4. 3/4. Okay? How about when y is square root of 3/2? What is u? 1 minus 3/4. Okay? Okay, so I'm just working out this one now. Okay? So it's minus 1/2, 3/4, 1/4. This u is like u to the minus 1/2, right? Because the square root is in the denominator. So this is equal to minus 1/2. Now you want to find antiderivatives, right? So it's minus 1/2 plus 1 here, right? U to the minus 1/2 plus 1. 3/4, 1/4. So this equal to 1/2 times 1, right? Minus 1 minus u to the 1/2. Okay? This one. And then 1/4, 3/4. So plug this in. Minus 1/4, square root 1/4. And then minus, so it becomes plus 3/4 of 1/2. Okay? So this becomes 1/4 square root of 1/4 is 1/2. Square root of 3/4 is square root of 3/2. Okay? So this portion, this integral is up to here. Alright? Now, so I'm going to substitute this back into this original one. Alright? Therefore, this integral 1/2 square root of 3/2 inverse of sine y dy is those two terms, right? So square root of 3 pi over 6, the first one, minus pi over 12, this guy. And this integral I just found out, it is this number. So minus this integral, minus 1/2 plus square root of 3/2. So, alright, so the final answer is this minus pi over 12 plus 1/2 minus square root of 3/2. That's the final answer. Any question? All right, so we are going to the next page, next exercise. And of course, if we have time, we can come back for more, all right? So whenever you have questions, you just ask, because today is a review. Whenever you have questions, I will answer. All right, so that's the next section would be 7.3, which is trigonometry integrals. The next one is this trigonometry integrals. For doing this, you have to use identities, trigonometric identities. Okay, so let us review some trigonometry identities before I answer your question, okay? Because I have to review it anyway, so. So 7.3. Alright, so 7.3. Yeah, 7.3. That's the trigonometry integrals. Okay, so must use, as I put it, must use trigonometry identity. Okay, so what are they? we have sine square plus cosine square is 1. We have tangent square plus 1 is secant square. We have cotangent square plus 1 is cosecant square. Okay. A good way of memorizing all this is that we use everyone has a way of memorizing those identities, and I can show you one way which I use all the time is draw like this. All right, and then I have this, okay, and I put down sine, cosine, 1 here, tangent, cotangent, secant, cosecant. Okay, now the way to read this is that the sum of the squares. Okay, before I go on, there are 3 triangles, right? They are upside down triangles. So the way to read this is that the sum of the squares of the top 2 is equal to the square of the bottom one. So if I read this, so this says sine square plus cosine square is 1 square, which is 1. Tangent square plus 1 square, which is 1, equals secant square. Cotangent square plus 1 square is cosecant square. So if I draw this picture, I know I remember all these 3 trigonometric identities. And also, the one on the diagonal are the reciprocal of each other. So, for example, sine x is 1/2 of cosecant x. Sine x is 1/2. 1 over. No, I'm sorry, not 1 over. And the cosecant is 1 over sine. Right? And the tangent is 1 over. Okay, from here, the cotangent is 1 over secant. Secant is 1 over cosine. And the tangent is 1 over cotangent. Cotangent is 1 over tangent. So the functions on the diagonal, are reciprocal of each other. So sine is 1 over cosecant, cosine is 1 over secant, tangent is 1 over cotangent, so on. So you see, if I know this graph, I already have 1, 2, 3, 4, 5, 6, 7, 8, 9 identities. Then I need to compensate this with 2 more, or maybe some more, 2 more at least. So one is sine of 2x is 2 sine x cosine x. This I just have to memorize it. Sine of 2 times x is 2 times sine x cosine x. I had to memorize it. And cosine of 2x is cosine square minus sine square. Okay, and this is also 2 cosine square x minus 1. But this is also the same as 1 minus 2 sine square. Okay. So, okay, and the last one, I can also use this tool. I can also write cosine square is 1/2 of 1 plus cosine of 2x. And sine square is 1/2 of 1 minus cosine of 2x. So, okay, so these two are really, I need to remember this. Okay, it's not that I don't have to memorize anything. I have to remember this. But for the other identities, I just have to memorize this picture, and then I know all those identities. Okay. I mean, of course, everyone has his or her own way of memorizing trigonometric identities. What I provide you is one of them. Okay. All right. So those are the identities. I mean, if there's any, I will give it to you more. But I think that's pretty much. If you can memorize, you can manage this, you should be no problem. Okay. All right. So let me now take questions from you. Yes. 21. 21. Okay. Let me write the problem before. I don't wait. Let me 21. 21. 21. That's 3, 4, 21. All right, 21. Okay, so 21 integral sine cube, right? Sorry, so difficult to read. Sine cube. I'm sorry. Sine. Okay. Sine to the 5, right? That's worse. Looks like 5 to me. Sine 5x cosine minus 2x, right? Okay. All right. So this is what? This is really sine to the 5 here, and then cosine squared here. This is this guy, this guy. Okay, this guy, this guy. So it is fine. So I want to integrate this. So I must use some kind of identities because those are just high powers. Right. 5 minus 2. Okay. So how do we do this one? So there are several ways I can do this. Okay. So let me just do this. So I'm going to let me do the following. So I'm going to break this sine x into two. One is sine x, one is sine 4x. Okay, because 1 times 4, I mean sine x times sine 4 is sine 5. Yes, and that's cosine squared. Okay. All right. So I'm going to write this out. Okay. So I have sine squared x, sine x. Now, sine to the 4 is sine squared, and then square, right? The square is 4. Why am I doing this? You probably can guess what I'm going to do, because I sine square. I remember the identity. Sine square plus cosine square is 1. So sine square is 1 minus cosine square. So if I work this out, let me put a book here. So it's integral sine x, cosine square x, right? So this is 1 minus square of this, 1 minus 2 times cosine square plus cosine to the 4th. Okay, all right. So this will be. So this one, right? So you see, I can break this into 3 terms. First term is sine x over